All right. Sweet. Here we go. So, our class is moving towards perimeter area stuff. Just the beginnings of record. Sorry. Just the beginnings of surface area and volume. So we want to start with perimeter and area. So I want to do some of my students' homework so that they can have an idea of what's going on as we move forward. Okay, so go back to here. And then let's see if we can paste this in here, hopefully. All right, sweet. That did work. Nice. I had to try a new Active Inspire wasn't working very well. So I had to kind of switch gears and try and find something different. So I tried Miro today. But if it works, it could be my new system. So we shall see. So far, I think it's going to be what I'm looking for. All right. Anyways, so we're looking at finding the perimeter and area for these figures. So the first thing we want to do is talk about perimeter. When we talk about perimeter, we're really trying to figure out the fencing around something. We're going to change that to green. So we're looking for the fencing around our figure. So whatever you want to call it, I'm going to start calling it base 1 and base 2. Actually, let's change that up. Oh, that took everything out. Okay, let's try this again. Only because I know what equation I did in the homework that I need to name this one base 1 and this one base 2. Okay, so we have two bases in a trapezoid. And the trapezoid does sometimes also have a height associated with it. Okay, but since there's no height, we're just going to be looking at perimeter right now. So we have a base 1 and a base 2. I think they call these legs. I don't know. What did I call it? I'm curious. Let's see if we scroll up. Oh, goodness gracious. Here we go. A and C. So I didn't even call it anything. Okay. There's a proper name. I almost want to say leg, but I don't know if that would be right. But anyways, we have a length here. We're just going to call it A, and a length here, and we're going to call it B. And we want to find the perimeter. What we're going to do is just add all four sides together. Oh, that's a stupid letter, isn't it? Why is B a stupid letter? Because we have base 1 and base 2. I don't want to name it the same letter. So we're going to name it C plus base 1 plus base 2. And what is this? This is the equation for trapezoid. Okay? That's the basic equation for a trapezoid. If I should move that up a little bit. Try and keep this, I don't know. Move this up over here. I'm just trying to rearrange things so that they look clean. I'm trying to do stuff. I don't know. I'm just trying to make it so everybody can see what I'm doing. All right. So if I'm looking for that, that's the equation for a perimeter. My justification is that's what the equation is. Like I can't change what an equation is. That's based on fact. So we're going to say A equals 3, C equals 3, base 1 equals 7, and then base 2 equals 13. And the reason we know all of this is because the picture tells us. If the picture tells us, we have to consider that given information. Otherwise, we wouldn't know what it was at all. Like we can't say anything about it. So the fact that the picture tells us is what we call given information. So now that we have that given information, I tell my students it's substitute and solve. So we're going to use substitution, and we're going to be able to find this perimeter now. Because A, if I highlight it, A is 3 plus, go to the highlighter and change it, C is 3 as well, plus, we're going to go to B1, base 1 is 7, plus, and then we're going to get our last one, base 2, and base 2 is 13. So all we're doing is taking these different colors that we have, 13, I think that was 7, and then this one was 3, and then our green was 3 as well. So just trying to color coordinate on where everything came from. Now the last step, all we're going to do is combine like terms. So we're going to combine all of our numbers together, and we call that combining like terms. Same thing if they all had x's. If it was 3x, 3x, 7x, 13x, we could just combine like terms. So I like to use that phrase more than I'm adding. Because a lot of times adding and addition property of equality sometimes get confused or get thrown off. I want it to be, we're going to add them all together. When we do that, 3 and 7 make 10. 10 plus 13 is 23, and then another 3 gives us 26. So that's how we should get the first problem. And then I'm learning this as we go, but I do think I saw new board. No. No. What I'm looking for. Wonder if you have a next page. Just trying to look. Oh, maybe. Oops, no. I'm just seeing if I can move this. Oh. Is that a timer? Oh, nice. Oh, this is pretty slick. I kind of like this. Ultra. Wow. We might use this in my classroom. I kind of like this. That slams a slide. Create a frame. Okay. Add a new frame? Oh. I see. Okay. Interesting. Yeah. I don't know what that means. Let's not do that right now. Let's see if we need a new board. Let's do a new board. Okay, so it kept the old board. Still got this one. So maybe just new board. So that'd be a bunch of tabs. That's interesting. But we'll see. So far, I'm really liking this program though. So kudos to the people that did it. I kind of want to shrink this up so that I get my full board, at least the majority of my board in here. So let's try that and see if that works. All right, go to the next problem. The next problem is this strictly perimeter? Okay, so yeah, we're just calculating the perimeter for these. All right. Okay. And then we'll go back over here and paste it in. And we'll Stretch it out a little bit. Okay. So find the perimeter. So first thing you should notice is we have a rectangle. So the perimeter of a rectangle is 2 times the length plus 2 times the width. Definition of perimeter of a rectangle. So we'll just do definition perimeter of a rectangle is, I think, good enough. So then we need to know what the length is and what the width is. So when we look at these figures, technically there's not a wrong way to think about this, but usually they talk when the length is usually, if you can visually see a longer side, that's usually what they define as the length. It doesn't always have to be that way, but just an idea. So we have the length is 7, width is 2. So I'm going to say that the length is 7, the width is 2, and that's what we call, once again, given information. Let's put it over here with the justification given. Okay. Then, once again, substitution comes into play. And we're going to get the perimeter equals 2 times the length plus 2 times the width. So all I did was I replaced my length with what my length actually equals. And then I did the same thing with my width. My width, width, width. That's what those are. Okay, so I'm just replacing my letters with numbers. Now multiply it together. So if I do that, 2 times 7 is going to give me 14. 2 times 2 is going to give me 4. Add them together. So this is just multiplication, or yeah, we'll just use it as multiplication, and then we'll get 18 when we combine like terms. You could do addition as well. I just think combine like terms gives you a better understanding for when it's 14x plus 4x. So I'm really trying to push that agenda. And that's it. That's all you got to do. And let's pull out number 4, and then we're going to move on. Because the next one I think is area, and that's a little not too bad. Hopefully it's going to feel like the same process, but we'll see. Open slide bar. I don't. I get a presentation. That's great, but that doesn't really help me in my frame by frame situation. Let me see if I can do this. Okay. Can I move that? Well, I guess I can. I wonder why these didn't go with it. Okay. All right, let's try that. So let's go here. All right. Let's start here. I want to make sure everybody can see it properly. Okay, so a circle. This is a special figure because the perimeter of a circle it's not tricky to calculate, but sometimes it's tricky to see. If you think about this, if I were to use a shoelace and go around this circle, okay? And I would start at one specific point and stop at that same specific point. I could straighten that shoelace out and then measure it. And I could measure that length. So when we find circumference, which is what it's called, what we are doing is we're literally taking the start of our figure and going around until we get to the stop of our figure, and we're cutting it. And then we're straightening it out and measuring it. That's what the circumference equation does for us. I know it doesn't seem that straightforward because it's 2 times pi times the radius, but that's essentially how that equation works. Is we are going to take right here, chop it up, and then straighten it out. So we're going to have that straight line starting here and ending there and wrapping it around our circle. Okay, so that's what's happening in these problems. So we have C equals 2 pi r. That is the, let's go, definition of circumference of a circle. Okay. Now, 2 and pi are 2 and pi. So the only thing we really need is the radius. And the radius is the distance from the center of the circle out to any point on the circle. And it doesn't have to be straight here. Like, the beauty of a circle is that it's equidistant all the way around, meaning the same distance, no matter where I travel in the circle, all of these are going to be 6 as I move it around. Okay? So, that's cool. So when I look at this, the radius is from the center out to the side. Sometimes they will give you the diameter, and that's when you got to cut it in half. But if they don't give you the diameter and they just give you the radius, just use the radius and call it given information. Okay, so then I'm going to get C equals 2 times pi times the radius. So we'll go ahead and color coordinate that. Radius, 6. We're plugging it in to that equation. We're just replacing the r with the 6, and we call that substitution. And if you know why you're doing something, it makes it so much easier to actually do it. Now, if I do 2 times 6, I get 12 pi. So I'm just multiplying. And then if we want to approximate, so they're going to do these 2 wavy lines to show an approximation, I could take 12 and multiply by 3.1415926535897, I think is the next number after. I don't know. Can you explain the Maclaurin series? I don't know this. I'm in 6th. Can you do some facts after? You should know this. You must be behind. What? Can you explain the Maclaurins? Wow. Let's keep it polite in here, please. And in 6, can you do some facts after? Yeah, sure, I can do some facts. Whatever facts you need. So we're going to do 12 times 3.14 is roughly enough to get you where you need it to go. And you can just hit multiply, simplify, however you want to state it is good with that. And then whatever comes out. I don't have a calculator right now, so I suppose since we all walk around with one, right? That was always the funny thing. You're never going to have a calculator. Times 12 would give us 37.68. So 37.68. All right. And that will get us our circumference. All right. So I've had some